Hello and welcome to today's .NET Managed Languages and Runtime Community Stand-Up. I'm Bill Wagner. I'm responsible for the C# docs. Helping to host today is Chet Husk. I'll let you introduce yourself.
Hi, everybody. I'm Chet Husk. I'm a PM at Microsoft for the .NET SDK, MS Build, and a couple other bits and bobs.
And we're super excited. Our guest today is Maoni Stephens, who many of you have probably heard of and seen her speak. She is, I guess, chief architect, primary person on the .NET garbage collector and memory management. So anything you've ever wanted to know about how the GC works, Maoni is always the person we ask questions of. So I'll let you say more about your role there, Maoni.
I think you basically covered it, Bill. Hi, Maoni. This is Maoni, and I'm the architect, and I work on the GC and been working on it for a while. So if you have any questions, I'm happy to answer them.
And that is pretty much the main thing that we've prepared today, is to get your questions about how the GC works and get the chance to have Maoni answer those and help explain it for all of us. So we'll be watching chat. Mm-hmm. And I guess while we wait for some people to log in and introduce some new, actually I'll go ahead and ask show the first one we already have no, I don't know the memory for that one. This is why I put on my glasses when I look at the chat room. But
that's a fun one to start with this morning.
Yeah.
Oh, we've got some detailed questions here. Someone knows the history of the GC.
So is the GC code still in one giant file?
No, GC is in two files. gc.cpp and gcprov.h.
So are they two giant files?
There's files that are bigger. So.
That's sort of an interesting question. that touches on that, though. So you mentioned gcc.cpp and .h. Those are C++ source and header files. What's it like working in a heavily unmanaged language for a runtime in an environment that is managed, right? How do you manage that split? Are there goals for the GC over time to become more managed code or less managed code?
So there's, GC is certainly not the only component in the runtime that is written in C++. I mean, if you look at GC code, we use very simple C++. We don't really use any very fancy language features just because, we like to know what's going on. When you use fancy language features, it usually means the language and the runtime will do a lot of stuff under you. So JIT is another component that's written in C, C++, or maybe it's just C. So there's a few other components, like type systems, and a lot of it is in managed code. And suspension, which is an important part of the runtime that many people mistakenly think is the GC, part of the GC, but suspension is a service that the runtime provides that the GC uses, plus some other, like debugger also uses suspension to suspend the managed threads. So there's, a bunch of them that are written in native code. The kind of benefit of writing the GC code in native code, not in managed code, is GC is already doing things that the managed threads are not allowed to do when GCs are moving things around, right? So GC doesn't need to, do all that stuff in order to put itself in that mode so it can do things with memory that you're not allowed to do. So it's actually a quite convenient thing. It's also better for debugging, in my experience, because you can look at all the things underneath, the raw stuff. So it's I think I could personally actually like it that it's in C++.
So there's kind of a related question there that I've always been curious about. Now that .NET runs on so many different kinds of devices and different operating systems, how much of the GC roughly is like specific to Windows, specific to Linux, specific to Mac, or IoT devices and so on?
Yeah, that's a great question. So if you just look at the GC code, we actually I don't believe we have any checks for the OS in the GC code itself, which means we've abstracted that layer out. So that is what we call the PAL layer. So that's basically the wrapper around the OS functionalities that the GC and some other components in the runtime need. Of course, because GC deals with memory, we mostly ask for the OS for virtual memory. And when we want to give it back, we call the OS to free it. So all that part is actually not in the GC code itself. Jan Volacek, he's another dev on our team. So he's mostly responsible for that layer. So when we started open sourcing, so when we started running on Linux, because we had been running on Windows for so long, right? So of course, before that, GC just called at the beginning, GC just called the OS APIs directly, right? So on Windows, that means virtual alloc, virtual free, and whatnot. But when we added hosting, which happened a very long time ago, we actually did already abstract that part out, because hosting needed to do something with the OS API, like handle them differently, because people who hosted us, for example, SQL, they wanted to provide their own implementation for example, virtual alloc and virtual free. So we provided that functionality for them, which meant GC code itself no longer sort of cared who implemented the virtual alloc. Right? So that was actually a convenient thing when we're bringing everything to Linux, which was, Linux, of course, has its own APIs to allocate and free virtual memory. So that layer was extended to cover Linux OS API. So GC could ask for memory and free memory on Linux and Mac OS.
Okay. So queuing up quite a few questions. I'll kind of just keep rolling through them. How hard was implementing GC regions? And I'll drop a question in the chat there to add as I can put the link to the original issue there for people who may not be familiar with that one.
Yeah. So regions is something that I started to write back in .NET 5. So I did kind of an initial implementation. And of course, the other engineers who work on GC continue to work on it. And we enabled it in .NET 6, in .NET 7, which means I started working on it in .NET 6 then, sorry. So I started in the last release. And Peter and Andrew and now Moko, they're the 3 other engineers on the GC team. They've kept working on it in .NET 7, and a few preview builds back, we made it a default. So we still ship the segments version of the GC in clr.gc.dl. That's a standalone GCDL, and there's a GC that comes with core clr.dl. That's the embedded GC. That's the default that you use. You can switch to the standalone version by setting the environment variable. So how hard was it? It was a lot of work, yeah, because the GC code for many, many years, it was, of course, as I mentioned, it was implemented with segments as the representation of how we divide up memory. So there's a lot of things that are that were applicable with segments that were no longer applicable with regions. So there's a lot of things that we got rid of. There's many things that we had to add. Of course, this is all happening on GitHub, so you could go take a look if you're interested. But I'll just give a few examples of how they differ from each other. So, for example, in segments, we have a concept called the generation start, right? Because especially with server GC, because we have very large segments, so it's very common that you have one heap that just has one big segment, right? So on that one big segment, you have all your 3 generations living on that segment. I'm going to leave out the large object heap and pinned object heap for now because they do live on different segments, but let's just talk about small object heap for now. So you got 3 generations, and we have this concept in the GC that's called generation start. So that indicates where Gen 2 starts on that segment, where Gen 1 and Gen 0 start on that segment. So each generation start is a little free object that we made. I have a video on YouTube that talks about why that's an object, not just a value. So for regions, because the invariant with regions that we have is that each region cannot host objects from more than one generation. So you have a region, it belongs to either Gen 0, Gen 1, Gen 2, or Gen 3, Gen 4, but I'm going to leave the 3 and 4 out for now. So you have a region that cannot have more than one generations of objects living on it. So you'll just belong to one of the generations, which meant we no longer have the reason to have that generation start object, right? Having a generation start object is not necessarily trivial, because we had to specially handle it for certain scenarios when you have pinning, where it can no longer be the min object size. It had to be a little bit bigger. So I wanted to totally get rid of that concept because it was no longer applicable, because now the generations are already distinct, right? Gen 0 just has its own regions and Gen 1 just has its own regions. So I got rid of that concept completely. So that's one of the parts that we did that actually simplified the code some, which was always nice. There's another thing that I got rid of, which is this heap expansion concept in the GC. So what that meant was with segments, that when you have, when you say like, okay, my heap is getting too large that it can no longer fit in one segment, so now I need to acquire another segment for, let's say, small object heap, right? So for small object heap, that can only happen during a GC. During a GC, we'll do our planning, which means we do a simulated compaction to see like, where are we going to be at if we were to compact the generations that we're collecting. And if we deem that as productive, we will go ahead with a compaction, right? But if we say like, well, if we do a compaction, we're still going to be in a situation that it's going to be way too tight. Way too tight means that I'm going to come out of the GC and I still don't have that much space for you to allocate, which means I just did all that work for a GC, but still I don't end up with a lot of space for the user code to allocate in. So that's not very productive, right? So if we're in that situation, we're going to attempt to acquire another segment, right? So that code path is what we call the heap expansion code path. So that code path is very, very complicated and not very performant because we just did all that work to do the compaction. But now because we've acquired a new segment, if we can, right? If we can, we can't. So if we can, that means we need to simulate our compaction once again to compact some of the things into that new segment that we just got, right? So that's a code path that was very good to get rid of. It's a lot of code there, especially with pinning. As always, we have to do something special with pinning. So got rid of that because we know, if we need a region, even when we're not in a GC, we can just acquire one. So that was a very nice property that regions, one of the very nice properties that regions gives us. Of course, this is not all, as with virtually anything in the GC code, there's, it's not very straightforward. It's not like, oh, you do this, then suddenly you're just in a much better situation, right? With regions, of course, it comes with other challenges. But, at the end of the day, we decided that doing regions will give us, a much more long-term benefits. So we still did it. It's a lot of work. So one of the challenges that we recently faced was, sort of how do you decommit regions? How do you give memory back, right? Mm-hmm. With regions, things are more complicated because before, when you just have one segment for the most part, we just need to worry about, because GC by design, it does not decommit anything that's in the middle of a segment or a region, right? So if you have free space, right, after we do a GC, we may discover some free space on the heap that we're going to make into free objects, and those free objects will be used to accommodate allocations from the younger generation. So we do not decommit memory for those free objects because the purpose of them being there is to accommodate new allocations. But we do want to take the opportunity to decommit end of segment space if we can, right? So that with segments, because, for example, most of the time we do ephemeral collections. So we just need to worry about that, end of segment space. And we can put in some perf heuristics that say like, oh, how much of the, how big is our Gen 0 and Gen 1 budget, which means, how much are we looking to consume that end of segment space. But with regions, of course, now suddenly you have multiple things to worry about, right? So that means we'd have to look at the end of regions for each region. Let's say if we're doing a Gen 0 GC, we need to make a decision. Should we commit all of the end of region space or should we not, right? Of course, it's the answer is rarely like we should always do one thing or the other. So we have this heuristic that Peter wrote the code for it. So it says that, we still do go with our previous principle of calculating how much space we need, which is we'll look at the Gen 0 budget, but now we've added, because the free regions that we have in small object heap can freely be used by any generation in the small object heap. I mean, in the future, this can be freely used by other heaps as well. But for now, for .NET 7, we just say that all the free regions in small object heap, they're freely reusable by any of the generations, so Gen 0, Gen 1, or Gen 2. So instead of only looking at ephemeral allocation budgets, now we look at all 3 generations in small object heap. But we don't want to give back, we don't want to decommit these regions too quickly, right? Because we don't want to be in the situation where, you just decommit a bunch of regions, but then you discover like, oh, well, we need to bring some back for allocation purpose, which means we need to, get them and commit them again, which is a pretty heavy operation. Mm-hmm. So we introduce this agent concept, which means that if you return the free region in the GC, and that region has stayed there, not being reused for a number of GCs, then we say like, even though nobody's using this, or somebody could use this, but it looks like nobody's using it for quite some time. So we're gonna let those go. So that's tuning that we had to put in. And of course, unfortunately, like people run these like micro benchmarks, which are not very realistic things, right? So like, you don't generally have a server application that you have, 48 heaps for, but you only consume, 50 megs of memory. That's not something that anybody uses in production. But we do want to, keep not just our big customers, with big scenarios happy, but also we want to not regress the small scenarios. So so we made, that was very, very, very exaggerated effect on micro benchmarks.
I'm just imagining someone with an equivalent of Tech Empower, right, for web frameworks, but for GCs, just allocating and deallocating.
We're talking about Tech Empower benchmarks, yes.
So I gotta say, there is a very sophisticated audience here today. Some of the questions we've got lined up for you, Maoni, are
all right.
So there's 2 that are related that I wanted to grab. So I'll cycle between here. First, what improvement in the GC do you find the most interesting or important? And the other one is, I remember Maoni from the Channel 9 days. So after so many years of working on the GC, how do you still come up with new ideas to improve it? So
I like the wet seals picture. Yeah, sure. So, I mean, there's always new ideas for the GC, right? GC is just a very interesting area. I mean, of course, I say this because as somebody who's spent most of her career working on this one component, obviously I like it. Obviously, otherwise I wouldn't still be working on it. I'd have moved on to something else. So there's, of course, GC, as it started around 1960, right? I think it's like 1959. So it's been many decades. And GC is a very, very heavily researched area in academia. There's, basically countless GC papers. I mean, I tell people, this probably makes me sound very nerdy, that one of my favorite pastime activities is just to read GC papers, because you could just think of an area in the GC that you want to know more about, and of course Microsoft provides us with this wonderful, the ACM library. It's all free access, so I just go there and I just search around and read some GC papers. It's actually a very fun pastime thing for me to do. I was actually doing it because I'm on vacation this week, so that's what I was doing yesterday for the most part. So there's always new ideas coming up. Also is sort of a self reinforced concept, just because if you look at the customers that we have and what kind of scenarios that they're running, it's yes, okay. The cat needs some attention. So I remember when I started working on GC, which was around end of 2.0 days, right? I'm talking like CLR, the framework 2.0, not core CLR 2.0. So at that time, I remember when you had like a heap that was, let's say, 200 megs, right? And people would be like, why do you have such a big heap? Like, what do you put on there, right? But now it's like you have a 20 gig heap, or that's nothing. 50 gig heap, that's, pretty common. So, and, one of the things I have, the perf kind of implications that I often have to explain to folks is that, the evolution of server GC, or rather like how it gets used in customer scenarios. So when we started server GC, I mean, of course, that's back in 1.0, so it's before my time. The idea that my predecessor had in mind was, well, if you're using server GC, that means you have one big process on the machine that's the dominant process, right? That's the most active, that does most of the work. So he designed it with that in mind, which was why, if you have server GC by default, it would create as many GC threads as you have on the machine, right? Number of logical CPUs. And that worked great back then, right? But as the years have gone by, you notice that folks started using server GC in all sorts of scenarios. Today, even our most dominant example of client workload, which is Visual Studio, is using server GC. So people have gone through the process of putting many processes on the same machine, and they're all using server GC, and they started interfering with each other because they're all trying to use the same CPUs should they happen at the same time. So we had to put in some configs to help work around that scenario, which is it lets you specify fewer GC threads and heaps. So, it's because our customers, it's of course good news for us. We have more and more customers who use .NET in more and more stressful, more performance required scenarios. So that means we have to keep improving it, right? We don't, we cannot stay stagnant, right? We have to keep making GC better, make it work better for more scenarios and more stressful scenarios.
So that segues right into one of the other questions, which is any recommendations on which GC mode is best suited for ASP.NET Core microservices hosted in Kubernetes? So should he pick server or workstation?
Yeah, so I was actually, last week, I was writing this document that I'm hoping that I would be able to make, more polished in the near future so I can publish it. So I actually have some flow chart that says if you're in this situation, should you go with the default, or should you put in some GC configs and what GC configs to put? So I think you would probably find that useful. But for, if you're running a container or rather memory constraint scenario, right? Actually, I should just say constraint scenario. So we call these containers, Kubernetes, whatever Docker that you're using, that's a constraint, you're constraining the resource in some way, right? From the GC's perspective, there's two things that concern the GC the most. One is the CPU, the other one's memory, of course. So you would, if you're running in these constrained environments, you may be constraining either one or both resources, right? You could be just having a CPU limit on your container, or you could be just having a memory limit, or have both, right? You could have other limit resources, of course, but the GC is generally not concerned with those. So let's say if you only have CPU limits on a container, Rich Lander actually had an issue on GitHub, and I'm not sure I have it right away, but he did a test on various container scenarios that I find very helpful. So, if you specify CPU limit, memory limit this way, he shows how many GC heaps you actually get, that kind of thing. So we might be able to, we should find it and post it somewhere maybe after this talk. Mm-hmm. So in general, I would say if you only limit the CPU, then you don't really, let's say you're limiting the CPU. If you think about it, it would be sort of like you're running on your own machine, except with your CPUs, right? So in general, when people limit the number of CPUs or the CPU time or however you are specifying the limits, it's unless you want to have some non-default behavior, right? Let's say you limited the CPU. Yeah, this looks like it. Yeah, the number looks about right. Thank you. So unless you want a different GC behavior, in general, I would say you're probably fine with just limited number of CPUs. The most problematic scenario is that you've limited the memory for your container, but you do not limit the CPUs that the container is allowed to use, and you're running on a big machine with lots of CPUs, right? So what happens there, and you're using server GC because you're using the ASP.NET. So what happens there is you would run into sort of like what we were just chatting about, that you have many GC heaps, many GC threads, but your memory, you want a very small memory limit. And that's generally not a very realistic scenario. And people do this just because they don't know, like, oh, I also need to limit the CPU. Like, nobody's doing this on my behalf automatically, right? Mm-hmm. So in the, I think back, and this was .NET Core 3.0, that's when I added the container support in GC, right? So I want to make a clarification here because there's often some misconception around this area. So, before .NET Core, we were always running on Windows. So people ran containers were implemented by the NT job object, right? So if you're running in a job object, this is the same with C groups, right? By default, you are already not allowed to consume more resources for the ones that you limited the container to, right? If you put on memory limit and you say, like, I want to, limit the commit, size to 500 megs on my job object, this is enforced by the OS, right? GC has no way to work around to allocate or commit more than 500 megs of memory for you. So from that sense, GC is container aware because it's just naturally enforced by the OS, the construct in the OS. But of course, if you're in a situation that you created 56 GC heaps, but you put on the container a very small memory limit, let's say 200 megs, it worked very poorly at that time. So in .NET 3, I added this, what we call container support, but I just want to clarify that before that, GC was aware of the container limit just because it had to be aware of it, right? It was just in enforced limits if you enforce such limits. If you don't put memory limit on the container, of course, you don't have such a limit. So in the container support that I added in .NET 3, that's just to say that let's not get premature out of memories, because let's not get into the mode where GC, because it has so many heaps and so many GC threads, it's going to allocate memory very quickly that it would just throw out of memory because it's before the next GC could even happen, it already tried to allocate more than what it's supposed to. So that's the container support. So GC handled it better for this scenario. We already had folks using containers before .NET Core 3.0. right? And it was working fine for them because, they were specifying the, sort of the memory or CPU limit that they kind of went with each other, right? They were not in a situation that they had, a huge number of CPUs that the container could use, but specify like a 200 meg memory limit. So it was working fine for those folks, but just not working fine for people who did not specify a CPU limit, but with a very small memory limit. Okay. But I should probably say, what GC mode. So, in general, as I said, if you are not in that situation, it probably works fine already on its own. So you don't need to specify any additional configs or anything. Of course, you can always think of extreme situations. Like I've gone through this scenario with some customer like years ago with .NET Framework. This was before .NET Core days, that they wanted to pack many, many instances of their server, their ASP.NET server process on the same machine. I think they had something like 500 instances. So in that case, we just told them to turn off server GC altogether, because it makes no sense. They had like a machine with like 24 cores or whatever. So, so there's really no reason to, if you have such small, amount of resource that each instance can use, then you might as well just turn off server GC. Mm-hmm.
Wow, that's nuts. I will say that for the user's question here about the ASP.NET Core GC, the default is server. Like that's set in the .NET SDK. So. the question is really, should you ever switch off of that? And
right. So there's one of the scenarios that you want to switch off of it is in that extreme scenario that I just mentioned.
Okay. So we touched on framework a little bit. Historically, GC cleanup would freeze threads when running on the default client or console WinForms or so on, and you had to modify the app config to set the server to true. Is this still the case, or is multi-threading GC on by default now, even in workstation mode?
So workstation means there's no multi-threading GC, right? It means there's only one GC thread working. So we, as we just mentioned, if you use certain kinds of apps like ASP.NET, it is already turning on server GC for you. So you don't have to do that yourself. But otherwise, if you have a standalone app that is not hosted by anybody, right? Hosted means somebody else is managing all this for you, and they could, of course, choose to turn on some GC configs for you. But if it's just your app, nobody's doing any kind of configs for you, then workstation GC is still the default. Because server GC, if we made this, I think years ago we had this discussion internally with some Azure folks that would we want to actually make server GC the default if you're running on the server SKU of the OS. But the conclusion there is, even when you're running on server SKU, even when you don't have very many processes of yours, you're still having tons of processes from the, that's running by the OS, and there's some of them are using .NET, right? Of course, if we're not using .NET, then this is moot. But if you're using .NET, you don't really want to be in a situation where suddenly every process is demanding all the CPUs for its own use when it needs to do GC work, right? And we don't really, there's another idea that we talked about, which is having some kind of central governor for the .NET processes running on the same machine or on the same VM in the same container, that kind of thing. I still think that's that has merit, right? You could have, because we do have customers that has a ton of different, hundreds of processes, .NET processes on the same machine. And I do believe that it does have merit to have some kind of central governor. So you could tell us, like, here's the processes that we think should be allowed to consume the resources in the most intensive way on this machine. So you can sort of divide the resource up on your, from the .NET's perspective and just make that config for us, right? So I think there's merit there. Of course, there's challenges there, which is, how easy we can make it for folks to express, like, how much resource I want to allocate for each instance of my server applications. And of course, as a central governor itself, if the environment's running low on memory, then it would have trouble kind of running, right? Getting to run on its own. So what to do there? How do we, sort of have some kind of soft guarantee that this central governor process gets to run when it needs to do its work? So there's definitely problems there to solve, but that was one of the ideas that I did chat with various folks about. And also I wanted to clarify, because you said historically the GC cleanup would freeze threads when running the default client, and do you have the server GC on by default? So that's not really true when it comes to background GC, right? Background GC does do most of this work without having to freeze the user threads. And that's the same in workstation mode or server. They both, they both have the background GC mode. So you could, and that's a default, right? If you, regardless of using workstation or server, you always have background GC on by default. So when we need to do a full GC and we think we can, we're not too low on memory, we generally always make the full GC a background GC instead of, the kind of GC that would freeze your threads as it's running. So you already get that, and that has been the case for many years. I think I turn on workstation background GC in .NET, maybe .NET 4, like .NET Framework 4, and server background GC came in. I think I enabled it in .NET 4.5. So so that's, like you don't actually need to have your threads frozen while GC is doing its work.
Okay. So another one that's related to changes that have been made in the GC, especially as we move to core. Can GC move the stack in core? I thought it could in .NET FX or in Framework.
What does that mean, move the stack in core?
I'm not sure.
I don't understand the question.
Okay. So I may ask you for Blue Spite if you can clarify that one, and we'll keep that one started, but we'll move on to another one. Why were the experimental .NET pauseless GCs never released to production? I think some people would be happy to eat the throughput cost.
So I have never used the term pauseless, right? I know that some GCs are named, there's one GC that's named pauseless, but no GC is actually pauseless. It's just a matter of how long the pause is, right? GC will pause, but as long as you don't notice it, I suppose you could claim it's pauseless. But I don't know if this was based on something I said maybe in a I don't know, MVP summit or something. So like years ago, I did write a this was never released because I never had time to actually make it production quality. So I did write a sort of incremental compacting GC, right? Which meant like we would not compact the whole heap all in one shot like we do with full compacting GC today, but we would divide that work up into smaller chunks. So you only needed to pause for much less each time that we compacted the small part of Gen 2. So I did write a prototype for that. That was, I don't know, 8-9 years ago. But as with, when you do any kind of new GC, it's a huge amount of work, right? As you can see, like it took us a long time to even do regions, converting segments to regions. Of course, we don't like a lot of the time that GC team has to spend on is just working with customers who are using the current GCs, right? Because we have, with the millions of customers, you can imagine the amount of issues that we get, and we have a small team. So we do spend a significant chunk of our time kind of helping, and the improvement on the current GCs. So to have a new GC that's even up to the experimental production quality, that's a huge amount of work. And I was the GC team for many years, right? We only started having a real team like in the recent years. So before that, it was just me, and I had to do everything else for the GC. So I never had the time to actually bring that GC to production quality. But now we have more people, which is great, and we're always working toward giving you shorter latency. That's the number one priority on our list. So, of course, we care about other aspects of performance as well, right? We always care about heap size, right? That's some people care about that a lot. We always care about throughput, but latency, if I have to rate these three things, then I definitely say that we spend most of our efforts working on latency. And that's going to remain that way in the foreseeable future.
I think that it interjects something interesting. I think just about how hard some of the problems you work on are. Chatting with Bruce Eckel once, he made the comment that the whole reason Java and C# exist is because memory management was so much harder of a problem than we thought. And I speak from experience, having never written a C++ program that didn't have a memory leak or a memory overrun or something somewhere. Especially anything of any size. So I think it's just amazing How much?
Yeah, I think, I know that a lot of folks, they're complaining about, GC, when GC has to do its work, taking resource away from you, which is of course true. And one of the reasons why I'm still here is because I want to keep improving that, right? So it takes, as efficiently as possible when it does its work. But I remember one of the, largest first party customers that we have, they spent literally many years fixing memory corruption bugs in one release. I think the number I was quoted was like 4 man-years, just fixing various memory corruption bugs. And as anybody who's fixed one of those, and I can tell you that most people do not enjoy that kind of work, right? If you have an AV, that there's people who love that kind of work, right? It's I debug AVs all the time. Like that's, if you have a bug in the GC, the end result is in general that you have an access violation, right? So, but most people on that team, they're just so tired of having to fix memory corruption bugs. So when they switched over to .NET, of course, it was a pretty big amount of work to switch over, but they were very happy that they didn't need to spend time fixing memory corruption bugs anymore.
Mm-hmm. So that and looking forward, this was one of the other really interesting questions. I'm really curious here as well. What's your opinion on using machine or reinforcement learning to tune the GC behavior?
Yeah. So we actually did do some internal experimentation on this reinforcement learning, mostly reinforcement learning on the GC, at least attempted to do so. And I do think this is an area that, I'm always keeping an eye out for, like what, for not just for development in the machine learning space, but also just opportunities to work with folks on these, right? The timing is very important, right? So if you want to work on a project, right, it's not just like, I'm going to schedule some time next month to do it. It also matters like who you get to work with, right? So I kind of took the opportunity when I had the opportunities to work with some machine learning folks. And so far, I haven't, given the amount of effort that we and they put in, that I don't believe we've come to anything that was very impressive. This is not to say that there's no merit in trying more in the future. One of the problems I discovered was in order to make progress in this space, that actually this is kind of true for working with any other folks, I think. So if you want to do something that's productive with the GC, that's with a serious GC anyway. So a serious GC means like for example, the one like ours is not the GC doesn't just work in what I call the mainstream scenario, right? Mainstream means, well, if you do a memory manager, it cares about basically the, things on the stack and, static variables. Those are the only things that hold on to objects, and we just need to worry about those. If you read GC papers, that's basically all they talk about, right? Then the rest is like, how do you be smart and have all these clever algorithms to reclaim memory efficiently there. But for us, of course, there's pinning, there's GC handles, there's a bunch of other things that makes the environment a lot less straightforward, right? So in order to make progress in this area, the other team, right? The other team being the non-GC team, right? So in this context, it means the machine learning teams that we worked with, that they actually do need some GC knowledge, right? This is not like, okay, let's do a fairly fuzzy problem, so we can just apply some machine learning fairly straightforward, or just, let's just worry about the machine learning part. We don't need to know anything in this space, but that's not the case with the GC. I found that I had to spend a lot of time just sort of communicating some basic GC knowledge to the other team in order to have them even get started. So that was a pretty big cost to pay on my part, right? So And then it didn't really work out for various reasons, because either a team had to go do something else because they had other higher priority things to do, or whatever reason that we had that made it not last long enough to actually get into something very interesting, right? I think with one of the teams, we got to the point where the other team, they did apply some machine learning, training on the a bunch of, sort of GC. They essentially ran like our in-house benchmark in various configurations. Then they tried to train on that and try to produce the most optimal numbers for the perf tuning purpose. So I think that was going on, but then the person had to go do some, they had higher priority things to do. So, we are trying, we have been trying, and I still think, like, should the opportunity come up in the future, we will give it more tries. But, the challenge there is that it has a pretty, big startup cost, whereas the other person would need to kind of get into the space some, right? They're obviously, I don't need to become a GC expert, but they do need to know the space in order to do something meaningful there.
Okay. So a couple other ones that I think are really interesting to look at is, does a GC provide equivalent or better memory safety to Rust?
Well, I would say, a garbage collector provides memory safety, right? That is kind of one of the most predominant goals of a garbage collector. So we do provide memory safety. You can't memory safety wise, that's if the GC does not provide memory safety in some way, that means there's a bug in the GC or in the runtime, right? So yes, it provides memory safety. So I'm not sure there's better memory safety there.
Okay.
Yeah.
And then another one kind of looking forward is, are you looking forward to or hope for any specific JIT or runtime features? For example, escape analysis. What would be in your wish list? And
so escape analysis is also something that our JIT folks have tried, right? So I think, when people hear these things, right? You hear like, oh, escape analysis, like it sounds pretty cool. Like, and Java has been doing this for years. I think you always have to put this feature in the context of the runtime that you're talking about, right? There's many features you could do in a runtime. So why does one runtime choose to do some of them, not others? I mean, of course, there's always resource constraints, right? We don't have an endless team, right? We have the team we have, so we have to focus our effort on the most urgent features, right? So escape analysis is, for example, it was very needed in Java because Java did not have structs, right? Where C# does. So for us, there's less urgency to do escape analysis, right? I think we had, there was one intern project that was doing escape analysis, but in order to do a fairly sort of meaningful analysis, there's of course a lot of work involved, right? It's not just a simple, like you come into method, you just, do some simple analysis and you can get, I think that's what the intern project did. And they discovered there's very little that escaped based on the simple analysis they did. So in order to take that far, you need to put in way more effort, right? So from my perspective, I'm mostly looking for, escape analysis was not really one on my list, just because I don't, I view that as something that, well, first of all, it is a JIT feature, right, mostly. So secondly, it's not like, I like it when people can say that, oh, I'm putting less stress on the GC, right? I mean, that's always good, right? It's good not just in .NET, it's good in any other environment. But I do not want to ask folks to make their own work awkward in order to achieve that. I think everybody, like if you have a serious product, like I tell this to every team that I work with, that has most teams I work with, they have a very, very large product, right? Something that runs on tens and hundreds, thousands of machines, that kind of scale. So they're serious about perf, right? If you're serious about perf, most likely means you're serious about memory. So you will be doing some memory related performance work. That's just kind of, to me, that's a given, right? I don't say this because I work on a GC. I say this as a performance person, as a performance engineer, right? If I work on a large server app that handles, billions of requests every day, you can bet I will concentrate a lot of my effort in memory performance and trying to reduce, whatever memory consumption I have, right? So I do, there's effort that you can spend on performance work, but I wouldn't want to ask folks to do some kind of awkward things like, oh, I have to know this internal detail of the GC and maybe allocate my objects this way to make GC less stressed out, right? I would not ask for that from customers ever, because that's just a very unreasonable thing to ask for. So I view it as part of my job to handle very stressful situations, right? So that means my work is mostly concentrating on the GC features, and I do look for things in the rest of the runtime that would allow us to build GC features that are able to handle more stressful and more variety of scenarios. So
that was really interesting. That also segues right into two other kind of related questions. When you're talking about our customers learning more about how the GC works to do their perf analysis, Paul asks, can we have an instrumentation API for the GC? And Boatswain also asked earlier should I know much about the GC or should I leave it to do the magic for me? So I'll go back to the first one and then.
Yeah, instrumentation API in what sense? Like, what would you like to be included in the instrumentation, right? Because I think we already have plenty of instrumentation in the GC, right? I think like our GC provides some of the most rich info that I've seen among runtimes that tells you like what GC is doing that's interesting from the user's perspective, right? So we have, events, right? On Windows, we had ETW events for many years before we open sourced, and on Linux we have the same not obviously not using the same technology, but we switched to using the Linux way of doing eventing, and then we added our own event pipe that does our own eventing in the runtime. We have various APIs, right? In .NET, I think this API was added in .NET 3, but I think I made it a lot more comprehensive in .NET 5. That's the Get GC Memory Info API, right? So that gives you a lot of info for the GC that you're looking at. It gives you, is this a compacting, sweeping GC? How much did it reclaim? How long the pause time was? There's a very, the object that it returns contains a very rich set of information. So if there's more information, of course, feel free to open issues that we can take a look on GitHub.
So I switched to the banner there. Under that section of docs should have all of the instrumentation that we do have already. And yeah, Paul, I'd say write an issue in .NET Runtime if there's questions that you don't have. And then I guess kind of the related one, how much should we know about how this thing works to try to write my program so it's
right.
It works well. Yeah.
So exactly. This kind of ties back to what I was saying, like what I would like to see from the kind of perf work that our customers are doing. So I do have a mem doc. If you go to my GitHub repo, it's just like Maoni0/mem-doc. So I have a mem doc there. That is the documentation I would love for our customers to read or to at least pick parts from, depending on what kind of problems you're looking at. So I don't think you, if you're curious, yes, thank you. If you're curious, of course, our code is open source, so you feel free to look at it. But I think as somebody who has their own job to do, obviously your effort should be focused on doing your job, right? So this work on GC is my job. But being able to know what to look for when you have a performance problem, I think that's a very important skill for anybody who needs to care about performance to have, right? For example, like I've come across folks who said, well, why don't you have a GC that has no pause, right? That would solve all my problems. So I asked him, I was like, do you think right now the pauses you're seeing are coming from the GC? Do you have a trace or something that I can take a look, at least to see if GC is working as expected, right? The answer was no, we've never done any kind of tracing or looking at the GC. We're actually not sure if the pauses are coming from the GC or from something else. And by the way, there's a variety of factors that could pause your threads, meaning taking resources from your user threads. GC is one of them, right? So with many of our first-party customers, we've come to the point where the customer cares about P95 latency, right? It means their P95 latency. And we make improvements in the GC, right? We can show you definitively that GC perf has improved by this much, and their P95 did not move, right? Why? Because there's many other factors that are now move into contributing to their P95. So, my advice to folks who are working on performance on your product is you should know, you should have some fundamental knowledge about the libraries or framework that you use. You don't need a whole lot. You just need to have enough. So when you have a perf problem, you know how to get started. Right. So that's a way that I view that you could use your time the most efficiently. Right. I mean, you could spend like half of your time just learning about the things that your product makes use of. But that only leaves you half of the time to do your work to actually make your product better. So that's probably not very good. Right. So but if you want to use your time efficiently, that's my advice. And please read the document to get started.
Okay. Then another sort of related one, going kind of deep here, is have you tested how well classical allocators do when used as a GC backend instead of bump allocators and compacting, whether it's gemalloc, snmalloc, minimalloc, and others?
It's very interesting. So we actually had a project that was using jemalloc as a backend for some of the allocations on the GC heap, that was allocated for .NET, right? So they definitely detected that the GC's own allocator was faster than the native allocator they were using. I think they were able to make some fixes in the version that they got, and they did get some perfect improvement. But I think in the end, of course, when it's hard to beat a bump allocator when if you have to do it's the same principle, right? jemalloc or snmalloc, they also have their own management that they have to do, right? So if you're comparing that with a bump allocator, like let's say you're in a scenario where you just don't do many GCs, or you do very cheap GCs, right? You mostly allocate very temporary objects. So when GC happens, you could make it happen not so often, if you could afford it. And all GC does is just reclaim a little bit of memory, which means the GC work, the amount of GC work that GC has to do is very small. It's pretty hard to beat that, right? Because, we just have, a big area of memory. You just, you can allocate very quickly. So it's, that's very, very performant. Of course, then you get into a scenario where if your scenario does trigger GCs very often, then of course you'd have, if it's often enough, then you'd have a problem on your hand, right? Then you have to look to see like, well, is this the designed behavior of the GC that it just can't do better, or is it something that I can do on my side to make it to put less stress on it? I mean, from my experience working with customers, it's very often that the customer actually didn't need to do all that much work on their side to achieve much better memory performance in the our environment after they knew like what to look for, right? You know, they took a trace and they're like, this is just something we don't even need to do, or this is something that comes from the interference that came from some other process and we don't even need to be running. So we just got rid of that. Then suddenly our GC perf, I mean, it's actually not, I always use the phrase memory performance because it's not really the GC performance that has changed. It's just like you put the GC in a different situation. Mm-hmm. So you see a better end result for memory performance.
Okay. And since we're getting pretty close to the end, I was going to finish with this one. What other improvement should we expect from the .NET GC, you know, .NET 7, and I assume 8 would come next, but, you know, you never know.
I think it'll come next. Yeah. Well, I mean, like I said, we have, you know, if I have to categorize in perf aspects from memory perspective, there's 3, right? There's the throughput, right? There's heap size, there's pauses, right? Individual pauses. So those are always areas that we're looking to improve, but sort of pause is definitely number 1. The reason for that is not just because we've had a lot of people who indicated to us that pause is important to them. It's also something that this kind of is one of the philosophies that I use when I decide like what features we should be working on next, which is if it's something that's very difficult to do or to influence from the user's perspective. And I view that as more of the GC's job, mm-hmm. right? If it's something that you could, you know, without a whole lot of effort, you could, you know, sort of change your code in some way, reorganize your code in some way, it would just improve the perf of memory, then you could already do that, right? I mean, of course, I'm not saying like, you know, that's all, again, I'm not advocating to everybody that you should spend all your time working on perf, right? Obviously, you want to add features to your product as well. But if it's something that's very hard for you to change your code to achieve, then I think that's more urgent for us to do. And I view that pause time is one such example, right? So that's why I think, you know, pause is definitely on that is our number 1 priority. So we're always working on things that would give us more improvements in that area.
Okay. This has just been amazing. I've certainly learned a lot. I see Chet sitting there nodding, going, yeah, this is
drinking from a fire hose.
Yeah. So I want to go back to just a couple of other things. Again, that's where most of the docs are. If you're not a native English speaker, if you just remove that en-us from that URL, then it'll automatically localize for you. Maoni has a number of YouTube videos here that explain a lot of different areas around the GC. Also super useful. And with that, I just want to say thank you so much for all the great questions. They were really insightful. And Maoni, for your time helping us and helping all of us understand a lot more about the GC.
Of course, you're welcome. And I'm glad to answer the very interesting questions. So thank you for that.
And with that, we will see everybody later. Thank you very much. And this should be available on YouTube streaming once the recording's all saved. Bye now.
Thank you. Bye.